The graph of the function f is shown in the figure above. For which of the following values of x is f prime of x positive and increasing? So we need to find the values of x where f prime of x is positive and increasing. And we're given this graph of f, the function of f of x, and we need to find where f prime of x is positive and increasing. Well, we know when the first derivative of a function is positive, that means that the graph of f of x is increasing. And we know that when the first derivative of a function is increasing, that means that f double prime of x is positive, which means that the original f of x function is concave up. So we know f of x is increasing because its first derivative is positive, and we know that f of x is concave up when the first derivative is increasing, because when the first derivative is increasing, that means the second derivative, f double prime of x, is greater than 0. So we need to find out which one of these points, a, b, c, d, e, is at a point on the graph that is increasing and concave up. Okay, so let's look at point A. Point A is on a region of the graph that is decreasing. Why? Because we see that the y value is going down instead of going up. Increasing functions have y values that are increasing as you go right on the x-axis. But here in this region, we see that the value of y is going down. If we go and make points on the y-axis, they're going down as the x value increases. So A cannot be the answer because we need the function to be increasing. Okay, then let's look at point B. Point B here is at a point on the graph that is neither increasing or decreasing. It's at this corner where this function was going down initially, and then to the right of it, it's increasing. So that means at point B, the function is neither increasing nor decreasing. So B cannot be the answer. In fact, you would say this is a point of inflection because on the left-hand side, we actually have concave down, and on the right-hand side, we still have concave down, but the value of our f second derivative has changed at this corner. And then let's look at point C. Point C here, the function is increasing at this point. We see that the value of y is increasing as we go through point C until we get to about the maximum of this local max right here. But the function is indeed increasing. But if we look at the graph at this point here, we see that it's this downward shaping parabola-ish. So that means at this point, the point C is in a concave down region, and we need it to be concave up. So C is not the correct answer. If we look at D, we see that the graph is going down again at this point. This means that this is in a decreasing portion of the graph. From the maximum of this hill up here till the minimum of this local minimum here, this function is going down. The y value is decreasing. So that means at point D, f of x is not increasing. So point D is incorrect. So E is the only answer left, but let's make sure it's increasing concave up. So if we look at point E, we see that the value of y is increasing from this local minimum down here until we get over here and pass through E, the value of y is increasing. So that means our function is increasing. So that's good. And we also see that our function is concave up. It's shaped upwards. It's above. It has a local minimum here. And to the left and right of this local minimum, we have this U-shaped function, which means that our function is also concave up. You could also think of concave up meaning going from decreasing to increasing, because that's what creates the local minima, and that's what creates this concave up shape. Whereas in the concave down region, we started from being increasing to decreasing, and that's what created a local max and created this downward shaping U, which creates the concave down portion of the graph. So at point E, we are increasing and concave up. That means E is the correct answer, because increasing means f prime is positive and concave up means f prime is increasing. So E is the correct answer.